In my previous videos, we are trying to create a simple multi-threading Java game with monitor pattern. In part 1, we represent the enemy locations in a hash map and use a thread-safe monitor to control the access. In part 2, we make the enemy move around. We also allow the enemy to kill our tank. The code we have developed so far doesn't pass the multi-threading standard. In this section, we will ask the following questions. How many threads are involved? We need to identify the variables that form the GameBoard's state. We need to identify the invariants that constrain the state variables. Finally, we will tell if all swing component methods invoked from the event dispatch thread, and are these methods labeled thread safe in the API specification. So let's get started. Let's copy the code to the Eclipse. I already did so. Here are the code. First, how many threads are involved? There are 3 threads. The main thread starts the program. Then we have updater thread, which animates the enemy tank. Finally, we have the swing event dispatch thread. See those override? Those code are invoked from the swing event dispatch thread. So totally we have 3 threads. Next question. What are the state variables belong to the GameBoard? Before we do that, let's first go back to review chapter 3. Safe publication. So to publish an object safely, we have these techniques. We initializing an object reference from a static initializer. We can store a reference to it into a volatile field or atomic reference. We can storing a reference to it into a final field of a properly constructed object. Properly constructed means we don't allow this reference to escape. Finally, we can store a reference to it into a field that is properly guarded by a lock. Don't forget about this. Immutable objects can be published through any mechanism. So now let's go back to the code. The state variables. We don't need to worry about those static final int because they already thread safe. They can be published with any mechanisms because static and final. Okay, there are several other state variables we need to examine. dx, dy, tank, laser, and empty, totaling 5. Next question, what are the invariants and constrain those state variables? dx, dy need to be updated atomically, otherwise your tank will show up in the location it has never been. And let's check what threads are using dx and dy. Let's see the GameBoard. GameBoard is constructed from the main thread, so main thread is using the GameBoard. You can print out if the main thread is using it. You see? False. Even dispatching thread is not invoking this code. That means that it's invoked by the main thread. And dx, dy is also invoked from the event dispatch thread. See, those remove reg is invoked from the key pressed. So we have 2 threads using dx, dy. without correct synchronization techniques we introduced in chapter 3. So from the perspective of multi-threading, dxdy is not properly published, and the invariance is broken. We need to fix. Next, yourtank and laserBeam is also shared among the multiple threads without a proper communication. Yourtank is first used by the main thread. Also, yourtank is used by the swing event dispatch thread. laserBeam is the same. So those two is not properly published. And the invariants, and there is no invariance between those two. And those are two independent variables, but they are not properly published. One possible scenario is the reference of GameBoard is returned to the main thread. However, when you're trying to repaint, the GameBoard is not completely constructed. So you could see yourtank and laserBeam in a partially constructed state. It could take the default value now, or even worse, it's partially initialized. You see dx, but you didn't see the dy's value. It could still be now. You see dx have a y's over 2, but dy haven't been initialized. It get a default value now, default value 0. So anything could happen if you not publish your state variables correctly. And don't forget about this. Remember, in absence of synchronization, the compiler, processor, and runtime can do some downward weird things to the order in which operations appear to execute. Attempt to reason about the order in which memory acts must happen in insufficient synchronized multi-threaded programs will almost certainly be incorrect. So your machine reorder your code if you are not publish them correctly. Finally, we have a monitor vehicle tracker. Again, it is shared among multiple threads, but it's not safely published. We could see a partially initialized MT. And finally, are all swing methods are called from the event dispatch thread? The answer is no. This repaint is called from the updater. It's called outside of the swing event dispatch thread. So let's check the API documentation. Documentation didn't say it is thread safe. It didn't make it clear we can call it from multiple threads. But let's look at the implementation. The repaint, if it's an instance of lightweight peer, it core itself. Otherwise, it generates a paint event and submits to the event queue. So eventually, the swing event dispatch thread is handling this repaint. So even though the document didn't make it clear, the implementation tells us the repaint can be called from multiple threads. And there's many Google discussion about this topic. And these are the problems for the code we already developed so far. And in the next section, we will fix it. So see you in the next section. Oh, great.